Hey, welcome everybody. My name is Damon Tighe. I am a mushroom fanatic. No, I'm a mushroom appreciator in Oakland, California. And I'm going to take you through how I do oyster mushroom cultivation using just a solar cooker. Before we jump into it, though, we need to understand like why I even want to do this. So I really have this big philosophy about the way that I'm trying to manage the land that I live on, which is basically get outside of the linear systems that we use a lot in the United States, which is like you go to the store, you buy stuff, you consume some of it, and the rest of it just goes in the trash. You have this kind of like linear pathway that comes through. And I want to try to build more ecological systems around the property, which is how do I kind of capture resources and then cycle them and then transform that into things that I actually want. So my general philosophy is leaning into existing cycles that have kind of created sustained life over the course of this planet and attempt to build as many of those cycles as possible in the place around me. And so that's everything from nutrient cycles to water cycles. And the biggest inspiration for that is literally just going out and spending time in ecosystems around you, understand how things are cycling there, what organisms are interacting with each other, what soils cause what sort of plants to grow, and getting that inspiration from the places close around you and their cycles, because that's going to give you the best model to try and generate those same systems close to home. So within that, if I'm thinking about that where I live in the San Francisco East Bay, and in general, this kind of holds true in a lot of places, especially if you're trying to grow kind of like food crops around your property. I want to think about a little bit of ecological succession. So, like when a home first gets built, or at least a contemporary home, especially in like suburbia, it's basically mow everything down, invert the soil in order to get the base layer for the foundation, do that, throw everything together, throw some landscaping plants in there, and put it on the market. And to some degree, it looks a little bit like Mount St. Helens after it blew up. You basically have kind of exposed rocks and not much suitable soil to get go. And if you have any soil there, it's kind of brought in from someplace else, and it's kind of that, home despot version of soil, which is mainly just forest products ground up and fermented just long enough, or pasteurized and composted long enough to just kind of make it slightly nutrient filled. But for the most part, it's not a great place for a lot of plant diversity to grow really, really well. And so, in order to get there, what you want to do is you want to slowly add complexity of organisms and organic compounds to the area around you. And in generalized succession, this takes place by, say, lichens and mosses first moving into an area, starting to degrade some of the rocks and things like that, starting to build up a slight organic layer in there. And then you have, weeds that can kind of make their way in there. Then you end up with perennial grasses and you end up with a shrub layer. Ultimately, you get to this kind of mixed diverse forest. And then long term, you get to these really old growth forests. And from a human point of view, we do most of our eating more or less out of plants that aren't definitely the exposed rock of Mount St. Helens just blew up and you're gonna go out there and find a meal. And not so much at the far edge of that, where you get these really, really mature old forests, or at least not where I live. Those mature redwood forests don't have a ton of food in them, but on the edges of them, where you find that intermixed forest with a lot more plant diversity, shrubs, and then even teetering out to the edge of those meadows, is where you find most of the things that humans are eating. And this is things like, fruit, grains, things like that. And so if I'm kind of managing a property, what I'm really hoping to do is get to a place where my property kind of looks like that, kind of that intermediate forest stage that's going to support a lot of these plants to produce a lot of human foods. In order to do this, in order to go from kind of like the bombed out, original suburban home to a place with complex biodiversity and the organic molecules of that, I need to think about nutrient cycles. And so, two of the ones that I think about most for the land that I'm kind of stewarding are nitrogen cycles and carbon cycles. And that's mainly because these are big inputs for plants. I know when people think about plants, they're thinking NPK, nitrogen, phosphorus, potassium, because that's what's all your fertilizers. And yes, those are very, very important. But I feel that nitrogen and carbon are the ones that are easiest to really lock in where you're at and not lose those by giving them away and not lose them by different methods of kind of land management. And so nitrogen, and carbon are both greatly kind of recaptured using decomposers on site. And for me, that's in this case going to be using oyster mushrooms to process plant materials into ways that I don't give them up. And those nutrients stay on the property and maybe have some more complexity to them compared to what they did coming into the system. In order to kind of start thinking about this in a little more detail, it really is helpful to go through and take where you're living and try to make a nutrient web from that. And this is kind of in the back of your mind. You want to think about where are things like NPK cycling through? How do I get to where I'm actually having cycles and not linear things that kind of pop through my system? So let's start at the top level. We kind of have our producers. These are our plants that are growing on the property. And this is what's capturing, right, carbon in the form of carbon dioxide into the plant material through, using sunlight and photosynthesis to do that and water. So these things are going to be what's producing the majority of my biomass and my kind of biological complexity as far as organic molecules go and diversity of organisms, because a lot of organisms are going to come in because you have certain plants. And this is why planting natives is really important, because you can then bring in that native insect diversity, which will further encourage more diversity on your property, like birds and things like that. So at the property I'm at right now, we've got a whole bunch of mature fruit trees, which are really, really lucky to have. We have mulberry, plum, apricot. We've got this crazy kind of trumpet vine that just grows like nobody's business, which to some degree is a headache, but it's also, from what I'm doing, kind of nice because I'm able to turn that biomass into stuff. We've also got orange trees, we've got, vegetable gardens, all kinds of stuff. But we also have what I call the red line, which are these things that we're buying to then bring into us calories for the most part in terms of like groceries, right? That our consumer layer is getting. So the consumer layer is getting, food from some of the producers that we have on campus. But a good number of those calories are coming from the grocery store. So that goes to me and Michelle. It goes to some of our chickens because we do buy some grain for them. They don't just eat the plant material around the property. There's a little bit that go to the rabbits. They get scraps from our vegetables that we eat. They do get a little bit of pelletized grain as well. Not grain, sorry, alfalfa. But then, we've got strict redliners, which are things like the cat and things like that. Ivy, gets external food, and then her poop doesn't even get to be recycled here. It goes externally into the trash. So things like this, I'm always trying to see if I can minimize or at least mix up a bit so that we're not just having these linear systems that just pass through the property. On the consumer level, we've got me and Michelle eating. We've got our 3 chickens, which are producing eggs for us. They also spend time eating plant matter around the property. They also spend time in the compost eating some of that biodiversity in terms of insects that come in for there. And then the rabbits, of course, they get fed every dang green thing they can get their hands on. Myces luckily loves weeds. He loves bitter lettuce. I think he gets a little high from it. But that's a picture of him with some there. But it's nice because that way, any weeds I have, I can feed directly to him, and he turns into great compost. And I can always take that compost if I want to and upcycle it even further by sticking it in our regular bin. All this production level at the top also produces a lot of biomass. And that biomass, I'm always trying to figure out how not to give up, because this is going to be the complexity, right, of all of the organic molecules that I want. And the last thing that I'm going to do is like give that away. And so 2 ways that I currently deal with the biomass is, well, actually 3 ways. Is it going directly to the compost, which works, get that, through there, and that turns into soil ultimately, comes back to the producers. But one of my favorite ways to do it is to actually take that biomass and get oyster mushrooms out of it. That's going to give me a little bit of food, which can go back to our consumer layer. And it's going to give me this broken down material that can go to the compost and turn into really great soil even faster. And then when I get too maxed out on materials coming through, I will also use biochar. I actually use this to process a lot of the super, super woody stuff just because oyster mushroom can do it. But man, biochar is a much quicker way of doing it. And what I like about it is it's a great soil amendment that gives me a way to trap nutrients in my soil. And biochar has this kind of crazy dynamic of it can keep the soil really aerated, but it also can keep the soil moist without it getting mushy, just due to that crystalline structure of burned down carbon. So really, really a good thing to learn how to use. I'll probably do a talk maybe sometime later on that because there's some nuance in how I run that. But for the most part, what we're going to focus on today is how do I do this? How do I take the organic matter coming out of the property and then turn it into oyster mushrooms for food, but then even more so, turn it into inputs again for my producers. And that comes through in the form of what I call fast mulch, which is basically the broken down woody and green substrates after they've been fermented with oyster mushroom. Sometimes I'll just layer that around plants that need kind of like an extra hit of stuff, and I need a little bit of a mulch layer, or that can go straight into the compost, where it definitely increases the breakdown of this type of stuff, man, probably like threefold to get me this really, really nice compost. The other thing I will also do with that oyster mushroom material is after I've fruited it, I can usually fruit like a jar like this 2 or 3 times. I will ferment this, so just cover it in water and let it sit. And I get this really, really nice liquid fertilizer that I can use. So a lot of times I will pour that off, strain it. Sometimes I'll solar cook this just in case there was something growing here I didn't want. That way I just have just the nutrients locked up and none of the bonus organisms. However, sometimes I want those bonus organisms because some of them, even though if you're a home cultivator of mushrooms, this is one you fear. If you're a gardener, this is also one you love. And so learning how to work with it's really important. And that's trichoderma. Trichoderma is a fungi that eats other fungi. And if you say have a jar of oyster mushrooms and you fruit them and you leave the jar outside, a lot of times trichoderma will invade that and start eating the oyster. And this is actually great because this is a wonderful soil amendment because if you have trichoderma in your soils, when you have, say, fresh root tips that are going in there, trichoderma will associate with those root tips and they'll basically keep away any of these pathogenic fungi. And so that's why you see trichoderma a lot of times in soil mixtures, is because it's a great way to keep pathogenic fungi from attacking your plants. So from that one oyster jar, we can get a lot of things. We can get mulch, we can get compost, we can get liquid fertilizer, and we can get a bioactive trichoderma that can protect my roots on new plants. So for me at the home, the green bin is the enemy. You don't want to give up your hard-won carbon that all of your plants have captured to the man. And so I think since we've been here, which has been 3.5 years now, I think I've only used the green bin once or twice. So that basically just sits there and does nothing, except I do haul stuff with it occasionally because it's kind of like a nice wheelbarrow that the city gave me. So in order to understand how I think about this nutrient cycle, you have to understand a little bit of what the property looks like too. And so we're lucky in that we live in this kind of decent sized footprint where there's a home in the front and there's a home in the back. And the home in the front just gets blasted by sun, which is great for vegetable gardening. So this gets a lot of the compost I make in the back ends up going to the front, and that's where we see a lot of kind of leafy vegetables and stuff you're just going to produce, during the summer being done there and kind of cover crops and things like that during the winter. And then as you move to the back, this is kind of what we call garden home. It really should be called canopy home because it's just all high canopy. I mean, it's a 4 to 5 degree shift in temperature by the time you move to the backyard just because of all of those trees. And this is where I've got things like kind of like low grade silviculture taking place, with the shade zone. The chickens are also in that shade zone, and that's so that they can kind of forage on the insects that are going after some of the plants. They can also eat some of the mulberries and things like that as they fall down. Our compost then is behind garden home in kind of a warm spot in the back. And then behind that is also a greenhouse for doing like vegetable starts and stuff like that. And then on top of the roof on garden home is where I'm doing most of my solar cooking. I would do it out in the front driveway if I lived out in the front home. But for me right now, it's just easier to access the roof. So I'm doing the solar cooking up on the roof. Um, I'm predominantly using oyster mushrooms, and that's mainly because over my multiple years of kind of growing fungi, man, oysters are the easiest thing to grow. I mean, they will grow on just about any substrate you give them. And if they struggle, just give them time, give them a couple rounds of like trying the substrate, freeing them out, putting them back on, and they will just figure a way out. I mean, they've got an amazing genetic toolbox to pull from. And this is why you hear like the overhype, by Stamets and folks like that, like, oh, we'll use it to like solve oil spills. It's like, yeah, it'll eat oil, but man, if there's something else there, it's going to eat that instead because oil's horrible to eat. Nothing wants to eat that except for like microbes that evolved to live near like, oil plumes on the bottom of the ocean. The other benefit is it's super fast growing. It's really resistant to many fungal pathogens. And because of its speed, it can outcompete a lot of things that would normally take out other fungi if you're trying to grow them. Also, a lot of cultivars that are out there are relatively easy to fruit. And in my experience, just cultivating natives from your local habitat, it's not a whole bunch of work in order to get them to fruit. And you really, really, if you want to do this, you really want to use local genetics. And that's because there's a whole bunch of bad things happening when non-natives get into places. People think about this with plants all the time, but this is something we should be really, really worried about with fungi. And, just like the wine industry, the more you can develop something local, the more you've got your own kind of like terroir, the thing that's like unique to your space, like lean into that. And that thing locally is going to want to grow in your area. And if it gets out, who cares? It's already there. And, to really kind of drive that point home, you should look at what happened with yellow oyster. Yellow oyster, which is this native oyster mushroom to kind of China and Japan, it escaped cultivation kind of in the Midwest and the Northeast. And now it's definitely pushing stuff out of those forests. And I know people will be like, well, show me the study. And like, yeah, nobody's shown a perfect study yet showing that, hey, this other native species is pushed out. But when you have something that takes over dead wood substrates like yellow oyster has done, and talk to anybody in the Midwest, I mean, it's a big deal. Like you go out in the forest and it's easy to find, it's great, it's edible, but nothing's a free lunch in biology. So because it's taking up resources, it's definitely diminishing populations of other fungi that are native to there. And this is something we don't want to see happen over and over on the planet with plants, with mushrooms, etc. So lean into using your locals. You'll have a much better experience with them, and you'll be getting to work on something novel that is exciting to those that live around you. So let's do some fungal basics because like I don't know where everybody's at. So um, tree of life, we're looking at like the diversity of life on the planet. Remember, fungi are much more like us than they are like plants. Yes, they didn't get taxonomically split until like 69 or 70. But they're heterotrophs just like us. They eat stuff, they don't make their own food by capturing sunlight. And so we need to think about that when we're working with them. Um, Oysters are an interesting fungus because, like I said, they're easy to work with. But people always ask, well, why, are they even worth growing, like from like an edibility nutrition point of view? And like, yeah, if anybody's ever eaten oysters and learned to cook with them, like they're a great edible if you learn how to cook with them. Especially, boy, if you can brown an oyster really well. Like I have like some friends that make what they call oyster bacon by baking it and browning it with olive oil, and oh, one of the best mushroom dishes I've ever had. And it's just super, super simple. But from a nutritional point of view, 3 grams of protein, 30 calories or so. That's, I guess, if you're like steaming the mushroom. Nobody steams oyster mushrooms. We're all cooking them in oil usually, or frying them with something else. There's definitely more calories usually when it comes down to actually what goes in your mouth. They're very high in vitamin B, and then vitamin D, they can be really, really high, but you have to fruit them in UV light in order to get the high vitamin D content. That vitamin D production is a response to UV light. They also contain a whole bunch of micronutrients like phosphorus, potassium, copper, iron, magnesium, zinc, magnesium, and selenium. And then on the kind of like mushrooms are good for you level of, they have, new stuff that stimulates your body in ways other foods don't. Fungi, all fungi have beta glucans in them. And I know when everybody talks about beta glucans, they're like turkey tail, turkey tail, turkey tail. And it's like, yes, turkey tails have a lot of beta glucans in them. They've got 3 times as much as most other fungi. But you know what? I'd much rather eat 3 times the amount of oysters than I would one amount of turkey tail, because they're okay, but it's like you're not going to eat like a meal of turkey tails. We're like oysters, you can eat a delicious, delicate meal with them. So beta glucans, which all fungi have and oysters have, they can help regulate blood sugar, they can help lower LDL, and they have a little bit of immune stimulation potential to them. And so there's definitely a medicinal benefit on top of just the basic nutritional caloric benefits to them. If we're going to learn to cultivate oyster mushrooms, we got to think a little bit about how these things generate themselves in the wild. What's that life cycle look like? So if we start with just the mushroom, you've got this mushroom. It has gills on it because we're going to do a simplified version today, right? We're not going to go up all the pores and all that type of stuff, teeth. Um, I've got some sort of structure gills that are producing spores. Those are going out in the world. They'll land someplace they like. They'll germinate. They'll become hyphae, basically single cell threads that kind of replicate and get longer and longer. Those hyphae can meet other hyphae. And so these hyphae at this point have just one copy of the genome. They meet another hyphae that they are compatible with, and they will basically start growing together. And this will be called mycelium. And this is kind of the white, fluffy stuff that if you flip logs and things like that, that you'll often see underneath a log. And it's basically the two genomes now living together, but not having sex. And so that mycelium will go through the world, digesting the world. Remember, fungi don't have stomachs, so they have to like push enzymes out into the world, break down their substrates, and then suck them up to make use of them. That'll be the main portion of this organism's life is mycelium. And so whenever you see a fruiting body, you got to think that that's actually just a small portion of the life cycle. It's like the apple to the apple tree, where that tree is the mycelium, and it can be there for decades upon decades, depending upon the species. At the right time of year and under the right conditions, that mycelium will start to form a hyphal knot, basically a really dense kind of knot of tissue that has a lot of the cells that will be needed for when you put up a fruiting body, i.e., that mushroom. And then, as kind of like in my area, when fall rolls around and moisture starts kind of hitting the ground, we get the primordia will form. And then once you get a good rain, what will happen is that little primordia will basically swell with water and then form your mushroom. So you can almost think about this like the dinosaur sponges you may have seen as a kid. You throw them in the water, and they all of a sudden grow to a giant, dinosaur. You didn't grow a whole bunch of new cells during that time. You just inflated them with water, and the mushroom is kind of doing the same thing. A lot of what you see in the mushroom is just kind of inflation from water. There's some replication that taking place in there as well, but the reason you can see mushrooms, one day, with some species or a couple days after a rain is exactly this quick swelling with water that will get you the fruiting body. And this is just important to think about, if you're going to get into cultivation. So from a cultivation point of view, if you're doing basic cultivation, we really only need to worry about this kind of red circle stuff right now. How do I maintain mycelium, and how do I take that mycelium, get it into a place that it wants to fruit and produce a fruiting body? I mean, if you're a high-end cultivator, you can then deal on the other side of the life cycle and think about spores, genetic diversity, and things like that. And now all of a sudden you are a breeder trying to make, new strains of the fungi you're working with. But for us, if we take just that portion of the life cycle, we can then kind of manipulate it into this what I call the cultivation life cycle, which is basically we're going to go from having mycelium more or less on agar plate. We'll basically upstage it using grain spawn, and then use that grain spawn to inoculate some substrate, which in my case is going to be yard debris, which then after it runs through all that substrate, I'll then focus in on fruiting it. And for the most part, you're only having to do the agar plate thing, a handful of times if you're just isolating something from the wild near you. And so you're going to end up spending most of your time between grain spawn and fruiting. Because once you get your first grain spawn, you could literally kind of keep this going forever if you're good at this. And so this is going to be the predominant focus of what we look at today is kind of like, how do I do the grain spawn? How do I do a substrate run and then get to fruiting? A lot of these steps require a degree of sterility, but not crazy sterility. I know when people have videos of cultivation online, people are like in hoods, where they've got flow stations, they're doing stuff. I just do everything like literally in like a plastic tub that's flipped upside down that I can look through and is sitting on two boxes that I can put my hands in that those I will clean, but I don't have to get crazy with this. Because you got to remember, in in the nature, fungi are competing with stuff all of the time. They've got all this like, chemical warfare that they've used. They've learned to like, facilitate getting rid of bacteria, and they've got, other mechanisms to, get rid of other things. Um, so we can kind of lean into that a little bit. We don't have to get crazy with sterility, and especially if part of this is you're just trying to make compost at the end. If something goes wrong, the worst thing that happens is you just take that and put it in your compost and then start over. And so remember, if you're working in a cycle, having a breakdown at any point isn't a huge deal because you can always just enter another portion of your cycle and then keep things moving. At some point in the future, I hope that we actually do understand kind of the succession that's taking place in substrates that allow fungi to then kind of take root and then take over. My gut feeling is you have bacteria that will take over certain environments, and then fungi have learned, specific taxa of fungi have learned to come behind a certain taxa of bacteria and then take advantage of their ecological wake and establish themselves. But we're not quite yet there as far as humans go. We're still just trying to figure out how to do mycorrhizal fungi, but that, is around the corner as well. So if we are going to do a little bit of cultivation, we should probably talk about how long have humans been doing this. So I actually thought that this was going to be much longer before I started digging into it. But from what I've read, about the oldest you can find evidence of is 6,000 or 600 current era wood ears being cultivated in China. And then about 600 years later, shiitake being cultivated in generally the same area. And this isn't too surprising because you have two wood decaying mushrooms that you could easily see how somebody could trip upon this. Like you find a log that's got wood ears on it, and you're like, man, I love these. I'm going to take these back to where I live. Go home with it. And then, you throw it on like some wood that maybe you've got stacked up for some reason, or you're just leaning it up against some dead wood. And then you realize that over the course of time, oh man, the other wood now is producing wood ears. So what could I do? Well, I could just take wood ear logs and I could stack them on a bunch of logs, and then magically they'll just start showing up, and I'll get this kind of like passive cultivation through stacking wood. And not too funny, but kind of funny, is that this is still the way you see a lot of shiitake people cultivate outside. They'll go through and inoculate the logs, but they're more or less using the same strategy, which is stack logs on top of each other, get at least fungi on some of it, and get the rest infected. When it comes to oysters, I'm also a little surprised that oysters are actually a relatively recent addition to the fungi that we're cultivating. So it really wasn't until World War One that we see protocols develop for cultivating oysters. And this is mainly because Germany was running out of food due to, stuff going down. And so they had a lot of people that had been working in microbiology and had been working with fungi a bit, and realized that they could take mycelium from oysters and then inoculate stumps and get these stumps to produce really nice yields of fungi. From there, you see kind of protocols get developed in India and capturing of all of their, or a lot of their diversity in the 60s. And then the 70s, you see Japan, China, Korea, and US really go gung-ho with oyster mushroom cultivation. Because once you get it, it is actually one of the easiest fungi to work with because of the diversity of things that it will eat. In order to prepare substrates for them, though, there's been a whole slew of ways that people have gone about this. You could, heat your substrate. You could use chemicals to treat your substrate. You could ferment your substrate. You could do heat and pressure, which is traditionally what most people are doing right now, some degree of heat and pressure. And then looking at all of these, I'm like, I like all these, but man, I really want something where I don't have to put fossil energy into it. And so that for me looks to be like fermentation, or could I get heat but use solar instead of fire so I don't have to burn stuff? And so solar is really what I've ended up landing on, just because my fermentation stuff didn't go how I liked. And then also talking to folks that do fermentation, some of them are actually supplementing with some chemical additives to adjust pH. And I'm just trying to do no inputs. That's just my style. I just want to be bare bones. So solar cookers are a great option for that, because once you have the infrastructure, it's there. You don't have to add anything to it. It just collects light and heats stuff up. Oldest solar cooker on record, 1767, a Swiss scientist built this. And to be honest, it's not too different from half the slower cookers I see today. There's basically multiple layers of glass to make a box that could get almost up to boiling. Most of the box cookers you get today will probably get you to boiling, but hey, 1767, I mean, you're still just trying to pour decent glass lenses. Man, spot on. Well done, Swiss. Um, so right now you've got about three more or less types of slower cookers that are really, really easy to find in the world. You've got box slower cookers, very similar to the one that the Swiss scientists made a couple hundred years ago. You've got panel solar cookers that kind of take light and reflect them to some degree, angling them towards a pot. And then you've got these parabolic ones, which are great at focusing light at one spot and getting it really, really hot. So as we go kind of left to right there, um, what you can see is basically the heating potential of these different units. So box cookers, I used to work with them a lot when I did cattle ranching in high school. This is usually what we cook most of our meals on. And the parabolic is really where I'd want to get to, but right now I'm kind of using a panel cooker more or less. And that's mainly just because of like access to it. And I actually bought my solar cooker for a different reason besides making mushrooms. So right now I'm using the Haynes 2.0 solar cooker. It's slightly parabolic. It's very, very lightweight. It's collapsible. And half the reason I bought it was that it was shippable. Mainly this company Heinz specializes in getting these things all over the world. And I really wanted to buy one for my friend Patrice in Madagascar, who, for those of you guys that have followed me since the pandemic, ran into a real tough spot in Madagascar at the pandemic because most of the food coming in was coming in originally on tourist buses to his town of Ndisibe. And all of a sudden they were having food shortages, and he wanted to develop basically an agricultural kind of system close to his town that didn't rely upon fire because it's bad for the forest that he manages and brings tourists to. And so he kind of did this huge thing of like learning all these different kind of agricultural techniques in order to remove fire from the agricultural systems, and then provide enough food for the town during this kind of downturn in the pandemic. And so this was a technology that I knew Patrice would like. And so I basically bought a Haynes cooker for him and a Haynes cooker for me. So that way we could kind of trade recipes, or at least, figure out if this technology was useful for where he was at. So I use this a lot to cook lunch with. Sometimes I'll cook dinner with it. I usually am just cooking things just in a glass jar, and I'll put that inside the pot that comes with the Haynes cooker. It gets hot enough that I can fry eggs in there. I can boil water. I can boil about half a liter in about 25 minutes on a good day. So it's a really good system, for being relatively inexpensive and looking kind of chintzy. Um, so in order to kind of like test, can I do oysters on this thing that I already have? I'd say the best place to do the test is on the substrate run, because substrate is where we're going to take, at least for my condition, we're just going to take random yard scraps and see if we can sterilize them enough to throw grain spawn at them and have it take over so that I can fruit mushrooms on it. So my first experiment, or one of my early experiments, was this. Remember, I was still interested in the cold ferment because, hey, that's nice. I just cover things with water and let it go. So I basically took what I had been using previous to solar cooker, which was the pressure cooker, which is, I would say, like the classic standard, right? I know I can get things sterilized. I just use an Instapot at home. I do a 2-hour cycle. So this is literally just random plant debris that's around my house on the ground. I've cut down probably, weeks ago, that have been on the ground rotting and whatever. Stuff them into jars, and then cold ferment one, basically cover it with water for like 2 to 3 weeks and just kind of let it ferment. Pour the water off, throw the spawn on there. I did the classic pressure cooker version of this, and then I took one and I put it in the solar cooker and cooked it for an afternoon, and then pitched spawn on it after it cooled down. For the most part, what I saw was not too surprising. Pressure cooker, because I was able to sterilize every last bit of it, right? It probably also breaks down stuff a little bit. I got really, really nice fruiting on it. And unfortunately, I was out of town when I was supposed to be doing fruiting for work. And so I kind of have these lackluster looking results too. I would have popped the top so I could have fruited them, but instead they just fruited themselves. Solar cooker worked. I could see mushrooms shooting out through there. I can see really good colonization of the substrate. Cold ferment worked, but it just wasn't as aggressive. And I think that's because the fungus is still dealing with all the other bacterial players in there to some degree. So I went, you know what? I like the solar cooker. I've got it. Well, I'm going to lean into that now. I think it's the way to go. And so in that process of thinking about this, I was like, well, if I really, really want to get things super, super sterile, if I want to get it similar to my pressure cooker, I can also lean into not just heat, but using cycling of heat in order to even drive more sterility. So there's this thing I used to do when I lived in an apartment in Oakland called Tyndall sterilization. I would use my oven to do this or just my stove. And the idea here is if I have a substrate that's got all these microorganisms in it, and I basically heat it up, and maybe I get it to boiling, and a whole bunch of stuff dies. Not everything's going to die because bacteria produce cysts and some other microorganisms produce cysts. So some of those cysts will make it through that first kind of like heat exposure. But if you give them time, like a day or two, what will happen is those cysts will be like, oh, cool. Everybody else is dead. Now's my time to come out and take over. So they'll come out of their cysts and then start to take over. And if you hit them with heat again, now you get to kill them. And if you do that, 2, 3 times, you've got now a pretty sterile substrate. And so this is a process known as Tyndall sterilization. And this was developed, boy, I think this is the same time as like Pasteur, or maybe even prior to Pasteur's pasteurization processes. So when I'm doing solar cooking with really, really dirty stuff and I'm doing like large like volumes, this is what I'll lean into a little bit. And the way I do that is I'll just like stuff a giant glass jar, like a gallon glass jar with my substrates, put it in the solar cooker, and then just forget about it. And then go back up on the roof and pick it up in 3 days. And at that time, it's gone through many heat cycles, cold nights, stuff got to wake up and then get killed. And that substrate's super, super sterile. So what substrates can I use? Anything. And yeah, anything. Like basically, if it's got cellulose or carbon that's slightly accessible, Oyster will go after it. So, like I said, I've got that creeper vine, so I will use that a lot of times because we're constantly battling keeping that from taking over the house or other structures. Are like leftover scraps from dinner from like cutting up vegetables. I'll pack in there. Leaf material coming from trees. I'll pack in there. The only thing to be worried about with like leafy stuff or stuff that's coming from like your groceries is you just want to make sure there's some woody stuff in there so that way when the stuff heats up, it doesn't just become like a sludge pile. You do need air pockets in there in order for mycelium to run really well. And so if you've got something that has the chance of becoming very sludgy, just pack it with some random sticks, some fibers, some weeds, whatever you got around. And oyster mushroom will be super, super happy with that. So actually on the left here, what you see is that is like some corn from the meal the night before, and I just packed it with a bunch of like vine trimmings. You can use all different size pieces of glass to do this with. I'm trying to lean more towards doing the gallon size glass jars, but I'm cheap, so I haven't bought enough to really work with yet. So I'm still working with the half-gallon ones, but really anything works. You kind of need to get over about maybe a fourth of a pint in order to have enough substrate to run where you could expect to get a mushroom out of it. Out of like a little tiny glass like this, you're going to get like a little tiny mushroom. So that's why it's nice. You can upsize the glass, get a bigger substrate run. You'll get more fungi on your fruiting. You could also use cardboard for this too. I used to use cardboard when I lived in downtown Oakland, and I had a deluge of cardboard because I was managing a 26-unit apartment complex. But within that, I'd always say, remember, the thing you're breaking down is also what you're eating. So play it safe. Substrate prep. With my gallon jars, they don't even fit in the pot that fits on the Hanes. And so that's cool though. I just pop it on there. I put the lid on. Good enough. It heats up enough. And if I do the Tyndall sterilization, a whole gallon thing like this gets sterile in a couple days. If I'm doing smaller jars, like the half gallon, that I can actually fit in the Hanes, and then I can just cover it all up, and that thing will sterilize like in an afternoon, which is kind of nice. Moisture level is one of the things you will need to learn to control when doing your preps. A lot of times when I'm trimming plants, I just use them green. I just stuff them into jars. So I'll get sometimes a moisture layer at the bottom, like liquid at the bottom after I've done the cook. And what I'll do is before I go to pitch my oyster spawn on there, I'll just flip the jar upside down, pour the liquid out, and then close it back up. The beauty about oysters is they can handle a lot of moisture, so you don't need to get crazy about it. Worst thing that'll happen is what you see in this photograph right here. the mycelium just runs until it hits the liquid layer and it's like, I can't breathe in that. So I'm done right here. And that's totally fine. It'll fruit perfectly fine from that. Probably a bigger danger though is being too dry. So mycelium is going to run fastest if your material is slightly damp. And so if I've trimmed a bunch of like garden stuff, it's been sitting around for a while, it's gotten really crusty and dry. A lot of times what I'll do is I'll cut it up, I'll put it in the jars, and then I'll just cover it with a little water. And I can either cook it like that in the solar cooker or just let it sit for an hour or two, pour that off, and then put that in the solar cooker. And that usually gives me close enough to the moisture level that I need for oysters to be happy. So let's talk about fruiting really quick. Once you do your substrate run, and this will take, depending upon the size of your jar, this could be a week, it could be 2 weeks. It also depends on the size of your air holes that you're going to use for your jars. So if you just use a lazy lid like this, because you don't have a lid for your giant gallon jars because they didn't come with them. This runs really fast because this allows for really, really quick air exchange. This could, though, potentially lead into some bad situations because things could crawl in there if you're using like an unsecure sort of habitat. So you could have insects go in there, flies, things like that. And that's why lids are preferable sometimes. But if I'm using this gallon jar, it'll kind of progress like this. I'll throw mycelium on top or spawn on top, and then it'll run down through the jar and eventually reach the bottom. And for a gallon like this, using an aluminum foil top, this is usually 2 to 2.5 weeks. And then if you forget about it, your mushrooms will try to sneak out in your closet like these have here. So this is like a second run of a jar. And I totally forgot about these because I was on a work trip. And so they just tried to fruit in my closet, which is not ideal. One big thing to be aware of when I do prep for my jars, I'm just going to pack a layer of grain spawn on top. And this is very different than the way most people do cultivation that you might watch online. They're going to take their grain spawn, they're going to mix it up in their bag and shake it up and stuff like that. And that's great if you're in a totally, totally sterile environment. That is not what you want to do for a system like this, because what I'm trying to do is I'm trying to provide a protection layer on top that is just the oyster mycelium, knowing that everything else beneath it is sterile at this point. If I do that, even if I get stuff on there, because there's always bacteria falling off your face, your hands, everything, even if something ends up in there, I know that that giant wall of grain spawn will basically kill that thing. And so that way I can be kind of dirty and still get away with the system working. Um, your different jar types will lead to different types of fruiting behaviors too, depending upon how big the neck is on the jar. The tighter the jar neck, the more likely you'll get a nice kind of fruiting bite that comes out the top. But usually I don't start to try and fruit until I see hyphal knots in my jars. So on the left-hand side there, you can see that kind of hard nugget starting right there. That is the fungus telling me, like, I want the fuck out of here. Get me out of here. And so at this point, what I would do is I'd unscrew the lid and then I would put this someplace where it's got airflow, but also can kind of stay moist. So I don't have a picture of it in this slide deck, but more or less what I'm using is I'm using, unfortunately, a styrofoam box. I want to build this out with non-styrofoam, but basically it's a styrofoam box with two holes on the side with fabric on them. So air can pass through, but nothing can get in. And then what I do is I leave a jar of water also in that styrofoam box. And then on the top of the box, I cut a hole and I just put a clear glass panel over the top. So that way sunlight can come down, strike it. I get that UV benefit and light helps trigger fungi fruiting. And so that's kind of like my makeshift fruiting box. But literally any place that is kind of like moist and airflow will work perfectly fine for fruiting it. So if I just fruit it outside in San Leandro, in the summer, Oakland in the summer, it'll kind of look like this. They'll dry out a bit just because I live in an arid climate where if I put them in the box, I get fruiting bodies that look like more like this because there's just more moisture around them. But airflow is one of the big things you need to be concerned with oysters. Otherwise, they'll get very, very leggy. So if you're seeing very skinny oysters, that tells you I need more airflow. Fruiting with these is really kind of nice in a jar system because you can fruit the jar multiple times really, really easily. Pick the mushrooms off the first time, close it back up, put it away for a couple of weeks, and actually add a little bit of moisture back to it. So sometimes I'll give it like maybe half a cup of water, depending on the size of the jar, and then put it back in the dark spot or put it back, away from stuff, and then give it some time to recover. And then once that's happened, I'll pull it back out and put it back in the fruiting zone again, and it'll fruit again. And you should be able to get, about 3 fruiting events with diminishing returns each time. Um, and by the third time after that, I mean, you could get it to fruit again, but it's going to take forever. It's going to be very little. So at that point, you move to composting it. So in order to make the fermented, basically liquid fertilizer, this is what I would do. I'd finish my last fruiting. I would then just cover the jar in water and then just let that sit outside in the sun for a week or so. What'll happen is all that stuff will sort of compress down. You'll actually see and smell a little bit of fermentation taking place. And then what I'll do is I'll just pour off the liquid, collect that liquid, and then use that like a liquid fertilizer. And I'll usually use that kind of sparingly. So I'll usually like use it, 1 to 10, 1 to 20 with water. And what I find is it's actually a really good plant immune stimulator. And I think this might be because you've got some of the chitin in there from the oyster mushroom breaking down due to fermentation. And I think when plants see chitin, they kind of go, oh, there's a fungus around. Maybe I got to turn on some of my chemical warfare. And or it could be the fact, even on this, you can see there's a little bit of trichoderma growing in there already. So I might also just be bringing trichoderma spores across, which maybe the plants like that. But either way, it's a great fertilizer. I've seen really, really good results on my vegetables and on my fruit trees using this fertilizer. If we've talked about now kind of like fruiting it, and we want to talk about how do I originally get my oyster to work with so I can make my grain spawn, we need to talk about how do we do auger work. And auger work is going to be the most challenging thing for any of you that are just beginning. So just know that, know that like you're going to have a lot of like, I got contamination again. I got contamination again. And that's totally fine. Everybody that does auger work, that's where they start out until you figure out how to be clean enough for the environment that you work in. And like I said before, you can be pretty dirty. I'm a pretty dirty guy, but we got to know where to be clean. So this is my typical workstation, which I know it's just chaos everywhere. But I can make a clean zone that's good enough for me to do auger work where I have very, very low contamination rates. And so this is literally just a Sterilite, plastic box setting on top of 2 smaller boxes so I can stick my hands underneath. And what I'll do is I will clean that zone with just a paper towel and either hydrogen peroxide first and then a little bit of isopropyl, or if I'm feeling lazy, I just do isopropyl and call it good. I'll wash my hands really well. I don't use gloves for this because I use enough damn gloves in my day job that I feel bad about it. And that'll be good enough for me to work with auger. Sometimes I'll also do spawn transfers in this same system, but I'm getting to the point where I'm doing most of those just kind of out in the open, haven't had many big problems. But really, it's like auger work is the only place I really feel like I need to be a little bit cleaner and a little more precise. So in order to make my augers, I'm just doing super basic. I'm just using malt extract auger. You can find this online for really, really cheap. I'll do 5 grams of that to 100 mils of water. I'll boil it using the solar cooker. I'll basically put water upstairs, put this in there, and then let that get to a boil. And that takes about 2 hours just because you do have a bunch of solutes in there. So it'll take longer for it to cook up than you would with regular water. You could also do this or on a regular stove. You could also do this in the microwave. You could do this in a pressure cooker. Up to you how you want to do it. The big thing is you just want to make sure your auger gets cooked beyond the boil for a little bit, at least a couple minutes, because that's going to get you uniform gelling later on. So don't just bring it to a boil and then start pouring. You're going to get some funky looking plates. Bring it to a boil, keep it there for a couple minutes, and then you can kind of pour. Also, it helps to let your kind of like auger cool down before you start pouring. If you pour with it super, super hot, your petri dishes will get really, really steamy, and that's okay, but it makes it hard to see what's going on in your petri dish. And so a lot of times I'll wait for the auger to cool back down where it's almost like comfortable to hold with a hand, but not starting to gel up, and then I'll pour my plates from there. Once I got my auger plate, if I'm trying to isolate some local fungi, what I do is basically this. I have a pair of basically steel tweezers You can get these online for pretty cheap. I don't know if like plucking your eyebrows or something. And I will just flame sterilize those. And then I will take the fruiting body that I want to work with, so a local oyster mushroom, and this is key. I'm going to tear it open. Do not cut it with a blade. With a blade, you're just going to introduce everything that's on the outside of that mushroom is now on the inside. So you want to tear it open, have your flame sterilized tweezers, and you're just going to go through and clip out a little bit of it and then pull that out and then put it on your auger plate and then let that go for a couple days. Check it every 2 days and then see, do I have contamination? Do I see mycelium coming out from there, etc. And so, a successful plate over the course of time looks like this. You've got one fuzzy, white, beautiful mycelium growing throughout there. But the majority of the times, it's going to look a little bit more like this, especially if you're working with wild stuff. You'll get bonus organisms all of the time. Even if you're trying to be really clean, even if your hands are clean, nothing dropped in there from you. It's just the nature of working with wild stuff. It comes with other organisms. But that's fine. You can deal with this. You can work with dirty. So this is a good example of this. This is a Ganoderma I was trying to isolate. And I've got like 4 different pieces of Ganoderma I put on here. And you can see all these other bonus organisms growing around them. So on the right-hand side there, I've got my little slice of Ganoderma. And I've got mycelium that's grown out from it. That's that kind of like white, yellow halo. But I also have a mold that accidentally got in there. And I can see a fight line between the mold and the Ganoderma, which is interesting in itself. But if I wanted to basically get that Ganoderma now, what I would do is I would go as far away from the mold as possible to the other side and take a little snip of that auger out and then just move that to a new plate. And that's going to allow me to isolate it. And if I do that a couple times, I will for sure have clean material. But going back to that fight line, and this is something for you medicinal mushroom people to think about. If you look at like traditional Chinese medicine, people always are like, the wild stuff is better. Wild stuff is better. And my true belief is that is because unless your fungus is being tested by something else in the environment, it's not producing a bunch of the compounds that it's producing in the wild. Just like what we see here in this fight line. This Ganoderma now is all of a sudden producing a lot of these compounds that are producing this pigmentation we see here. And that mold is also probably producing some too, coming from the other side. But that chemical warfare, I'd be not surprised if that's where a lot of the really useful compounds are that people are hoping to get from their medicinal mushrooms. So I'm not telling you to take your medicinal mushroom farm and start, adding mold to it, but just something to think about. So here is that example of, or here's another example of taking basically a messy sample that was wild, right? And I've got a little halo here of mycelium from the thing that I want. I grab that, I move it to this plate, and I get a little bit growing out from there, but I can also see that there is maybe something I don't want growing right there. That might be bacteria or maybe a mold. And so I take another chunk out over here, far away from the contaminant, and I move it to this plate. And now the next round, I've got a clean auger plate. And this now I know is just the organism I'm interested in. And so just time scale on this, this is about, a week each. So each one of these, I'm waiting about a week for things to grow out and then be able to tell if I can grab a new piece and move it on. All right, so that's how to basically grab a wild strain. And now let's talk about the core of your home mushroom cultivation, which is basically keeping grain spawn. Because you want to be able to do the auger stuff. It's really cool to be able to do, but you don't have to do it every time because that would just burn through a lot of hours. And so you really want to get to the point where you got your grain spawn and now you can regenerate it. So the grain spawn I use, and this is through playing with a lot of different grains and actually sort of by accident, I ordered a giant thing of like rye grains at some point because that's what everybody was using back in the day. And the company I ordered from like screwed up and sent me a bag of millet. And I was like, yeah, cool. I'll just roll with it and try it. And man, millet's way better. And then after I started posting that I was using it, a bunch of folks that actually do like full scale important like mushroom cultivation were like, oh yeah, that's what we use too. And that's mainly millet's kind of preferred for a couple of reasons. It's really low in contamination and it has a really small size, which means you've got more nucleation sites per basically volume, which means if I add this to substrate, I'm going to be able to get this to penetrate the substrate better and be able to colonize the substrate faster. So I do quick and easy, basically millet prep, which is basically I'll fill a third of the jar with millet. I will just top it off with water. So I'll add water slowly until the water just rises above the millet. And then I'm like, good enough. And then I'll go put it up in the slower cooker. I'll put it in the pot. I'll put water in the pot. So there's a base layer of water in there. And then I'll put my millet jars in there. And then I'll let those just kind of cook for like a full day in there. And that gets me a good, reasonable millet, cooked millet to work with. So now the trick is getting that agar into your millet. And so what I'll do is I'll do this inside the still air box underneath that plastic kind of makeshift hood, more or less. And what I'll do is I'll sterilize my tips of tweezers, and I'll go in there and I will cut out the agar and then move it on top of the grain. And what this will do is this will allow that mycelium to then slowly grow into the grain and take over. And what you'll end up with is ultimately a jar that kind of looks like this. It'll be solid white by the end. And if you leave it in there long enough, you'll have the mycelium trying to get out, like what's happening in this jar right here. And so if I've already got a spawn jar at this point, now this is the cornerstone of my home cultivation, because that jar right there represents two things to me. It represents the ability to inoculate substrate in order to make mushrooms, but also is the starting point for me being able to make more of it. And so what I will do is I'll take a spoon that I sterilize either with heat. Like sometimes I'll just put spoons in a jar on the slower cooker and let them go up there for a day while I'm cooking other stuff. And those will get hot enough that I know pretty much everything on them is dead. And then in the still air box, I would do this. I would take that spoon, I would open up this jar, and I would take a scoop out of that spawn jar, and I would go into the next grain jar. And I want to make sure that this is the first thing I do. I go from spawn to a grain jar, because that's going to reassure me that I'm regenerating what I need for my next round. Or I can take that jar right there and inoculate multiple grain jars. So if I'm using these little tiny jars like this for my spawn, I find that I can do 3 more spawn jars off each one of these and still have a scoop to then do a substrate run with. And so the big thing here, once again, is I'm going to take that grain and I'm going to layer it on top and kind of pat it down. So once again, my grain beneath I know is sterile. And the only place I have to worry about contamination taking place is really the surface, right? I have to worry about molds and stuff getting in there. But if I give a nice fat layer of oyster mycelium there, it will fight any little spore bacteria that lands there to death. And so this is a way to kind of operate slightly dirty, but still be able to cultivate stuff. So always protect that next generation by giving that solid layer on top and by doing the spawn to grain first. And then once I have that, then I will do the transfer of the leftover spawn to a jar of substrate that's been cooked. And at that point, I've basically regenerated my spawn and I started a substrate run. And that's kind of the whole system in a nutshell. When I do this presentation in person, we'll usually stop at this point, bust out the plastic tub, and then everybody will do basically a transfer of grain spawn to grain, and then a grain spawn to a small jar of random debris from my house, so they can also do a run of mushrooms. But in a nutshell, that's my system. I just wanted to get this out there because I know it's something people have asked for years. So hopefully this is helpful. Let me know if you've got questions. Happy to field questions. There's a lot of innovation still to take place in this space. So happy and excited to see other people kind of take this concept and run with it. All right. Have a good one. Take care. Bye.